you hear static on the radio signal, but you can't pinpoint where it's coming from. And of course, being able to see it with the camera, we can pinpoint where it's coming from. We can see how energetic the lightning flashes are. We can even infer how deep where they're originating from, which cloud is producing them. So we can learn a lot now that we can finally see the lightning. We had to use a synthetic noise because the actual noise that the radio instrument is picking up is beyond the human ear. So we picked a noise that sounded like an electrical discharge. In other words, a big spark. That's what lightning is. The first day of spring, when the sun is edge on, or the rings are edge on to the sun, and so the rings are not as bright during this first day of spring. It's called equinox. And so the rings are not as bright, and so the night side is suddenly much darker, and we can suddenly distinguish the lightning flashes from just clouds illuminated by ring shine. When it finally got dark enough at night, we pointed the cameras there, and wonder of wonders, there were lightning flashes, and took a series of pictures. And in one picture, there'd be no lightning flash, and the next picture, there'd be a lightning flash, and the next one, maybe there was, and maybe there wasn't. And so it was very clear that something was coming on and going off.
There was an observation that suspected lightning in the radio noise, and but it was not clear where this radio noise coming from. The explanation, the best explanation, was lightning, but you never know what's the location of that. We put together the lightning images knowing the time and the radio noise knowing the time, and just match the times and see that the sparks on the in the images are at the same time as the radio signals.